Let me set the scene. We're on the Discovery shuttle, several hundred feet apparently above the International Space Station, looking down not only at the ISS, but of course the Earth beneath it. So let's have a look at this short clip and I'll come back to you.
Used to seeing this in the simulator, and this is the ultimate high definition, seeing it with your eyes. Here we are crossing by Lake Michigan and Chicago, straight down below the station.
Pause it there, just as a reference. There's about 10-11 seconds between the start and the finish, okay? That got me thinking. If I take an image at the start of this footage and one at the end, somewhere like where we are now, like 11 seconds later, and then I superimpose them on top of each other, I wonder if there's much movement from the International Space Station. Because if there isn't, like there isn't in this instance, I'm going to use it as a line of sight to gauge the speed not only the shuttle is travelling at, but of course the International Space Station. And it turns out when I did an overlay, there's no difference whatsoever. The solar panels move slightly, as we're going to see in a minute, but the actual body of the space station is exactly the same position, and so is the Soyuz rocket, which is docked at the bottom. And that is what we're going to use as our line of sight, to gauge and see how fast these guys are travelling across the Earth. So here's image 1, the start of the journey, obviously highlighting the Soyuz as our line of sight target. Image 2 at the end of the journey, 11 seconds later, again highlighting the Soyuz as our target. And just before we go to the speeds, here's the overlay. This is both images overlaid on top of each other without moving or doing any alterations. You can see there's some slight change in the solar panels itself, but the main body of the space station and of course the Soyuz, which is what we're going to use as our line of sight, remain exactly the same, sync up perfectly, thus making it quite a good tool to use as a line of sight to give us some idea of speed. Now, between the 2 points of reference, there's 120 miles. I know it says 121, but it's 120 miles between the 2 points of reference. So we've got the distance of 120 miles, and we've got the time of approximately 11 seconds. So let's see how fast these guys were actually traveling. Okay, over at the speed calculator, distance 120 miles, time 11 seconds, and we calculate and we get a speed of 39,272 miles. So using the Soyuz which is obviously docked to the International Space Station, using the Soyuz as a line of sight from the shuttle, which is several hundred feet above the International Space Station, and locating 2 points of reference over on a bit of footage that is 11 seconds long, we're able to get a rough guesstimate at how fast they're travelling. And it would seem NASA need to slow their bullshit down a bit. You're supposed to be travelling at 17,000 miles an hour or 17,500 miles an hour, guys. But it would seem in the footage we've just seen, official footage, you're travelling at 39,000 miles an hour. It's a bit too fast, guys. That's like 23,000 miles an hour faster than you're supposedly travelling. Again, another special effects meltdown where someone's not really thought this out very well. This of course only happens when you're lying or you're deceiving. And of course in this instance we've caught the International Space Station bang to rights, and we can thank the shuttle Discovery for highlighting the absurdity of all of it.